Before we get into the demonstration portion of this video, let's take a look at a quick recap on how this project began. There's currently a race amongst the tech giants to develop the first fully autonomous vehicle. This project explores autonomous features on a smaller scale by focusing on radio-controlled vehicles. At my disposal is the Vatera V100-C RC car. It will be connected to both an Arduino Uno R3 and a Raspberry Pi 3 Model B. The primary function of the Arduino Uno is to control the electronic speed controller and the steering servo, while the primary function of the Raspberry Pi is to get the input from the Raspberry Pi camera module and convert it into steering instructions that are sent to the Arduino Uno for it to execute. The need for the Raspberry Pi arises from the necessity to utilize the OpenCV software. The first phase of the project was to identify and understand the parts that make up the Vatera RC car. A thorough understanding was needed of the ESC and the servo motors that drive it. The next phase involved connecting the Arduino Uno to the ESC and the steering servo. Phase 3 involved connecting the Arduino Uno to the Raspberry Pi. The Arduino program was installed on the Raspberry Pi and a test integer value was sent to the Arduino. Next was attaching the Raspberry Pi V2 camera module to the Raspberry Pi itself. A small test program was created utilizing the OpenCV to capture video footage. Video footage of a vehicle driving on a road was downloaded, and OpenCV software was utilized to convert it into a format that would be needed for the autonomous RC vehicle. Most details were stripped from the footage, and the remaining footage consisted of black scenery with white lines. The white lines represented the road lines, of course. A small segment of the video footage was cropped out, focusing on the shoulder line. This small segment will be crucial for translating the video footage into steering controls. The first milestone was to connect the Arduino Uno to the ESC and the steering servo. Second milestone was to connect the Raspberry Pi to the Arduino Uno and send a test signal to it. Milestone 3 was connecting the Raspberry Pi V2 camera module to the Raspberry Pi. This camera module will be crucial in converting road footage to steering instructions. OpenCV was crucial in the vehicle's navigation. A black line was laid out across a white background. The reason for such high contrast is because all other attempts proved futile. The Pi camera was insufficient in distinguishing the object of interest from other generic objects in its view. As the initial proof of concept, the vehicle was placed on blocks and was navigated along the track by hand. Once the code was fine-tuned, the vehicle navigated a small portion of the track on its own. The RC car is capable of navigating a larger track, but due to the camera limitations that were just discussed, a smaller track was designed. To further demonstrate the RC vehicle's capabilities, footage of a vehicle on the road was downloaded, and the line segment was extracted. You can see how the RC vehicle turns with the curvature of the road. Proximity sensors were installed on the front and the rear of the vehicle. If the RC vehicle encounters an obstacle in front of it, the speed is reduced to 0. And if the RC vehicle encounters an obstacle behind it while it's moving forward, the car will accelerate in an attempt to avoid a rear-end collision. This project was designed to get an appreciation of the difficulties that car manufacturers must undergo on a daily basis when developing fully autonomous vehicles. With many car manufacturers actively seeking fully autonomous capabilities, we'll see fully autonomous vehicles on the road sooner than later.